Alright guys, so you have a worksheet today, circuits and Ohm's law question set, and I just wanted to go over some of these questions for you so you'll have more luck. Now, the first page, first side, is super easy. All you are doing is using Ohm's law, voltage is equal to current times resistance. So it says, look at the diagrams below the simple circuit. Calculate the current measured at the ammeter. So it gives you two bits of information. It gives you this, which is the resistance. It gives you this, which is the voltage. And so all you need to do is solve those two values for current. Again, you can draw it as one of these little triangles. V is equal to IR. So if you want current, you just put your finger over the I. That tells you it's voltage divided by resistance. So it's just going to be 9 volts divided by 5.2. Easy. It'll be the same for this guy over here. So for number 2, you're doing the same, but you're trying to figure out what the resistance is. So you got the voltage right here. This 1.5 volts is your voltage. This is your current, right? Your current is equal to 0.025. So again, if you go up to this, if you want to find the resistance, it's just going to be voltage divided by current. So 1.5 divided by 0.025, and you're golden. And then finally, the the third iteration is trying to find the voltage. So again, you have the current here, you have the resistance here, and it's just voltage is equal to current times resistance. So to find the voltage across this resistor, it's 1.2 times 2.5. Now I'll give you an answer. Questions 4 and 5 are easy enough. We talked about it in class. Just think about your traffic when we talked about traffic. Why does resistance decrease in the circuit when more bulbs are added in parallel? You got the lanes, right? Okay, second side is a hard one. Alright, so these are very similar to the ones we did in class. So I'm just going to talk through how you did them. In fact, no, they're not the same. They're similar, but not the same. Find the total resistance of the circuit. This is series, so the resistance is just, you add them up. 6 plus 2 is 8. Once you know that the resistance, the total resistance is 8, then, let me write it down. Then all you're going to do to find the current is, again, look at your V is equal to IR. I mean, you can just use this triangle over and over again. If you want to find the current, you know what the resistance is. We just said it's 8. We know what the voltage is. It's 12, so 12 divided by 8. That gives you your answer right there. Calculate the voltage drop across each resistor. So now, once you've done that, you've got some kind of current, whatever that is. You're going to use that multiplied by the resistance, because again, voltage is equal to current times resistance, right? So if you know what the current is, you just calculated that, you multiply it by 6, that will tell you the voltage drop here, that will tell you the voltage drop here, current times 2. And then the power consumption, just remember, I guess power is equal to voltage times current, or if you really wanted to do it as a triangle, you could do it like that. Power is equal to voltage times current. So that is it. That's number 6. Number 7 is exactly the same as we did in class. The only difference is, what's the only difference? The only difference is, what's the only difference? The only difference is that it is parallel. So what that means is, instead of, adding these resistors, you have to add the reciprocal of them. So 1 over the equivalent resistance is equal to 1 over 6 plus 1 over 2. In fact, let me just go ahead and do this for you. So again, I can't just add 1/6 and 1/2. I got to make sure they both have the same denominator. So what I'm going to do is I'm just going to multiply this one by 3, multiply this one by 3. That gives me 1/6 plus 1 times 3 is 3, 2 times 3 is 6. 3 6s is the same as 1/2, right? That's all I did. 1 plus 3 is equal to 4 over 6. Which is equal to 2/3, right? You can boil that down to 2/3. So 1 over the equivalent resistance is equal to 2/3. So the equivalent resistance is equal to, if I flip this side, I got to flip this side. It's equal to 3 over 2, which is equal to 1.5. That is the total resistance of the circuit. So now you know the total resistance. You can find the current doing the exact same thing you did over here. I is equal to V over R. The other one, I will just help you on here, the voltage drop across each resistor. Again, 12 volts. If you're a little electron, you got 12 volts, you got 12 joules of energy. If I decide to go this way, I've got to give all 12 joules to this resistor, because that's the only one I'm going to see before I get back to the battery, right? And it's the exact same over here. I've got to give 12 volts here. It's actually what we call Kirchhoff's loop rule, which basically says in any loop, like I'm drawing a loop right now from the battery through the resistor, the total voltage has to be 0. So if I gain 12 here, I'm going to lose 12 here. And then you would have to find the current. I actually don't have that, so it's almost like a C part 2, is find the current going through here. Again, to find the current, it's voltage divided by resistance. So I've got 12 volts divided by 6 ohms. 12 divided by 6, I can do this, It's 2, right? 2. So I've got 2 amps going this way. And then 12 divided by 2 is going to be 6 amps going this way. 12 volts divided by 2 ohms is 6 amps going this way. And then you can calculate the power easy enough. 6 times 12 is what, 60. And then 12 times 2 times 12 is 24. So that's that one. Alright, I'm not going to go over 8 and 9 because it's the exact same as 6 and 7, except you have 3. So for example, this one is going to be 1 over the resistance is going to equal 1 over 1 plus 1 over 2 plus 1 over 2, right? You just keep going, and that's it. So that one's easy. These ones are a little bit trickier, but they're not as bad as you think. Actually kind of fun. I stand by that. I genuinely think they're fun. With this one, you've got to find the total resistance of the circuit. So when we do that, what we need to do is we got a mixture of series and parallel. So we're going to take these two first and see if we can figure out what the equivalent resistance of that is. So I've got 1 over 2 plus 1 over 6 is equal to 1 over R. Actually, didn't I do that one? I did. 1 over 6 plus 1 over 2 turned out to be an equivalent resistance of 1.5. So these two are equal to a 1.5 ohm resistor. So now what we've got to think of it is we have another circuit with this 1.5 ohm resistor here, this guy, and then the 2 and the 6 are acting like another 1.5 ohm resistor, right? So what we do is we've simplified this. So we said the 2 and the 6 are equal to a 1.5 ohm, and now these are in series with this 1.5 ohm, so 1.5 ohm plus 1.5 ohm. The total resistance is now going to be 3 ohms, and that's how we got the answer down here, 3 ohms. That is the total resistance of the circuit. Then what we're going to do is going to start building it back up again. So if I want to find the current through the battery, V is equal to IR. I want to find the current through the battery. It's going to be voltage divided by resistance. 9 volts divided by 3 is going to give me 3 amps. Right, I did that right. Yeah, 3 amps resistance, 9 volts, 9 divided by 3 is 3 amps. So this one's done. And then I need to find the voltage drop. So this one is a little bit more complicated, but we're almost done. For this guy, let's do this guy first. We know voltage is equal to current times resistance, right? So I have a 3 amp going through a 1.5 ohm resistor. So 3 times 1.5, that is going to equal 4.5 volts. Okay, so the voltage here is 4.5 volts. But again, I want to think about this loophole because I'm gaining 9 volts here. I lose 4.5 volts here. So if I go along this way, I've got to now lose 4.5 volts as well in order to be back to 0. So the voltage drop here is 4.5 volts. And it's the same if I go the big loop, I gain 9, I lose 4.5, that leaves me 4.5. I've got to give that 4.5 volts to this one in order to go back. And then you just keep going, and that's it. So 11 is like the piece de resistance because you've got to add 8 and 4 to turn this into a 12 ohm resistor. Then you got 1 over 12 plus 1 over 4, whatever that may be, and then you add that to a 1.5 and you're good. So that's it. I hope this video was helpful. Friday we'll go over any problems we're stuck on, and then we shall move on. All right, take it easy, chaps. Have a good day, and I'll see you Friday. Ta-ra.